In Lecture 9, we're going to take a look at templates, which are ways of defining patterns of related functions or patterns of related classes that just differ from each other in terms of some data types and perhaps some integer constants. Here on slide 2, we have the mymax function overloaded. In one case, we have mymax receiving two int parameters and returning an int value. And in the other case, mymax receives two double parameters and returns a double value. Now, these function definitions are completely identical except for the parameter types and return types and for the variable names. Now, the parameter types and the return types, of course, matter. That's what really makes these two functions different from each other. The parameter names don't matter at all. We could change x and y in the second implementation of mymax to I and j so that the parameter names between the two functions were identical, and that would not change the behavior of either one of the functions. We can also easily imagine a variety of mymax functions for chars, for unsigns, for long integers, etc. A template allows us to define an entire family of either functions or classes that are identical in terms of code, but may differ in terms of data types and certain constants. If you have a template defined, then when a template function is called, for example, the compiler will instantiate or generate at that point a type-specific version of that function, which will be called with the arguments that were provided. Let's take a look at this on slide 4. Over on slide 2, we have the regular code for these two overloaded mymax functions. Here we have a template called mymax. And the way you define this template is to simply take the function that you had written using specific types. So I took the int version of mymax here. You simply replace the data type int in the three places that it occurs with some identifier name. And purely by convention, people tend to use capital T as the identifier name to stand for the type name in a templated function. Once you've replaced the data type with capital T or the identifier of your choice, you then simply stick this notation, template, and then in angle brackets, type name T, close angle bracket, and you're done. You have now created a template function that will be instantiated each time mymax is called based on the arguments that were passed into the mymax function. Now, in the original version of C++, the type name keyword had not been introduced, and so what you used instead was the class keyword, and you can still use the class keyword, and you will very likely see this in other people's code. The meaning here is identical to using type name. Here on slide 5, we're calling mymax 3 times, once with 2 int arguments, once with 2 double arguments, and once with 2 char arguments. If I call mymax with 2 int arguments, the compiler will automatically instantiate or generate for me an instance of the mymax function that takes 2 ints and returns an int, and that's the function that will be called. Later on, when I call mymax with 2 doubles, the compiler will instantiate a mymax function that takes 2 doubles and returns a double, and call that function. And still later, when I call mymax with 2 chars, the compiler will instantiate and call a version of mymax that takes 2 chars and returns a char. So each time you call mymax, if that specific instantiation of mymax does not yet exist, the compiler will create it on the fly so that you can ask for the MyMax of any two comparable objects of the same type. This main function continues on slide 6. Here we're illustrating a couple of problems that we can run into. If I call MyMax with two arguments of different data types, the compiler can't figure out what to do, because the compiler has been told that the MyMax template will work if the data type of each of the two arguments is the same. So here the compiler is going to print an error message saying that it can't find a version of the MyMax function that takes a char and an int. Likewise, if we call MyMax with an int and a double, again we'll get an error from the compiler. However, we can explicitly specify what data type we want to instantiate MyMax with by using a data type name in angle brackets. So here, MyMax with char in angle brackets means instantiate the version of MyMax that takes two chars and return a char, and call that function with character A as the first argument and the value 9 as the second argument. And I'm sure you all have memorized that the character in the ASCII character set whose value is 9 is the horizontal tab. So in effect here what we're doing is we're computing the max of the little a character and the horizontal tab. Now little a is 97, so what we're going to get back from this is little a. Similarly down here, I'm specifying int in angle brackets to force an instantiation of MyMax taking two ints and returning an int. In this case, the double 7.1 is going to have its fraction chopped off, and what I will get back is the max of the ints 3 and 7. So I'm going to get an int 7 back as a result of this function call.